approximating distributions using a Poisson approximation to the binomial distribution. So starting with a binomial distribution, if n is large and n times p, the mean of the binomial, is less than 5, then we can use a Poisson distribution as an approximation to the binomial. The approximation improves the larger the value of n is and the smaller the value of p is. So a larger value of n and a smaller value of p will give you a better approximation. Reasons for using this approximation include having a value of n which is very large, so there are no tables available, or there are just too many calculations using the binomial formula, so it's impractical. So an approximation is a better way forward. Example 1. We have 100 trials and a 2% probability, so there are no cumulative binomial tables available, and we're looking for the probability that x is at most 5. So looking at the conditions to use a Poisson approximation, the first condition is met, n is 100, we need a value that's more than 50, and n times p is 2, and 2 is less than 5, so the second condition is also met. So the mean of the binomial distribution is 2, and the Poisson mean, which is lambda, will also be equal to 2. The binomial is a discrete distribution, so is the Poisson, so there is no continuity correction to apply, so we're still looking for the probability of less than or equal to 5. And from the Poisson tables, you get this. Example 2. We have the following binomial distribution, and we're trying to work out the probability that x is at least 7. There are no tables available for these values, and using the binomial formula leads to too many calculations. So let's see if we can apply an approximation instead. Now the following two conditions are both met. N is 60, so this condition is met. N times p is 4.8, that's the mean of the binomial, and that's less than 5, so the second condition is also met. So lambda is 4.8, which is the mean of the binomial, so we have the following problem to solve using a Poisson approximation. There is no continuity correction on this side, we're going from a discrete to a discrete distribution. And using the Poisson tables for a lambda value of 4.8 gives us this. Using this computer model to work out the exact probability with the binomial distribution, so without an approximation, gives a probability of 0.202, which is similar to our approximation. So this approximation is very good. And all because these conditions have been met. Because the approximation is good, the graphs for the binomial distribution and the Poisson distribution with the mean of 4.8 should be similar, as can be seen here.